Good morning, children. Today we are going to see about extraction of metals. So in this class we are going to see briefly about minerals, ores, extraction of metals of least reactivity, extraction of metals of middle reactivity, extraction of metals of high reactivity, refining or purification of metals and corrosion. Okay, so first we will learn about source of metal. Where does metal occur? Metals occur in earth crust and in sea water in the form of ores. So what is meant by earth crust? Surface layer of the earth. Okay, so most of the metals are present in earth crust and it is also present in sea water in the form of ores. Seawater contains many salt such as sodium chloride, magnesium chloride, etc. Okay, earth crust is the major source of metal. Understood, children? So metals mainly it is present in earth crust and it is also available in seawater and it is in the form of ores. So now we will see what is meant by mineral. Minerals are naturally occurring substance which have a uniform composition. Okay, so minerals are naturally occurring substance which have a uniform composition. Now, ores. What is meant by ores? The minerals from which a metal can be extracted are called ores. Okay, so ores means they are the minerals from which a metal can be extracted. Now, already we have studied about the reactivity series of metals, isn't it? Are you remembering? So, metals found at the bottom of the reactivity series are least reactive. Okay, so here in this picture you can see the metals found at the bottom of the reactivity series or least reactivity or less reactive metals. So the less reactive metals found in nature in free state. Okay, so example for less reactivity metals are copper, gold, silver, mercury, etc. Okay, so these are some of the less reactive metal which is available in the form of free state. This copper and silver are also found in the form of sulfide and oxide ores. Now, metal found in the middle of reactivity series such as you can see here zinc, iron, lead, hydrogen. Okay, so these are the metals which is found in the middle of the reactivity series. They are found in the form of oxides, sulfides or carbonate. Okay, so they exist in the three forms in the form of oxide ores, sulfides or carbonate ores. And metals which is found at the top of the reactivity series, they are never found in free state because they are very reactive. Example for the metals which is found at the top of the reactivity series are potassium, sodium, calcium, magnesium, aluminium. Okay, so they are never found in free state. They are very reactive. many metals are found in the form of oxides. Okay, so most of the metals are found in the form of oxides. Why they are found in the form of oxides? Because oxygen is abundant in nature and is very reactive. So we know atmosphere contains oxygen, isn't it? So metals which are found in the form of oxide. Why they are found in the form of oxide means because they can react with oxygen which is found naturally in the atmosphere. Now we are going to see briefly about extraction of metals. How we can extract metals from its ore. So, based on the reactivity, metals can be classified into three parts. They are most reactive, medium reactive, least reactive. Most reactive means metals which are highly reactive. Medium reactive means they will react in medium manner. Least reactive means they are very less reactive metals. So, there are three major steps are involved in the extraction of metals from its ore. They are concentration or enrichment of ores. Okay, so the first step in the extraction of metal from its ore is concentration or enrichment of ores. After concentration of ores, they can be converted into crude metal. That is the second step, that is conversion of concentrated ore into crude metal. Understood, children? Next, last step is refining of impure or crude metal. As the crude metal which we obtain contain lot of impurity, it has to be refined or it has to be purified. That is the last step of extraction of metal. So what are the three major steps in the extraction of metal? First one is concentration or enrichment of ores, then conversion of concentrated ore into crude metal, then refining of impure or crude metal. Understood, children? So let us see briefly about the extraction of metal. Okay, so now here you can see the flow chart which is describing the extraction of metal. So first step is what? Concentration of ores. Yes, so we know based on the reactivity of the metals, they are classified into three. They are metals of high reactivity, medium reactivity, low reactivity, isn't it? So metals of high reactivity, how they can be extracted? First, they have to be undergone electrolysis of molten ore. After that, they can be converted into pure metal. Okay, and metals of medium reactivity involve step. So if it is in the form of carbonate ore, we will undergo calcination during the extraction. Then if it is available in the form of sulfide ore, we will undergo the process called roasting, and after that it can be converted into oxide of metal. After that it is reduced to the metal, then it is purified. Okay, then metals of low reactivity means first it can be, if it is available in the form of sulfide ores, it undergo roasting process, then it can be converted into metal. After that it has to be purified. Okay, so these are the steps involved in the extraction of metals. We will learn briefly about this now. So first step is concentration of ores. So what is mean by concentration of ores? Removal of impurities. So when the metals are available in the form of ore, they contain lot of impurities such as soil, sand, stone, silicates, etc. Okay, so when we are mining the ore, it contains impurities. So the method of removing impurities such as soil, sand, stone, silicates from mines ore is known as concentration of ores. These impurities which are present in the ores which are mined is called as gangue. Okay, so what is meant by gangue? Ores which are mined often contain many impurities. These impurities are called gangue. Okay. Now, first of all, concentration is done to remove impurities from the ores. We know when we are mining the metal ores, it contains lot of impurities. Impurities means dust, unwanted particles. Okay. So, concentration is done to remove impurities. The concentration of ore is also known as enrichment of ores. So process of concentration depends on physical and chemical property of ores. So these are some of the examples of process which are applied for concentration of ores. They are gravity separation, electromagnetic separation, froth flotation process. So about these all process we will learn in higher class briefly. Okay, so now you should know about this. For concentrating ores, what are the methods they are applying? Gravity separation, electromagnetic separation, froth flotation process. Okay, these are some of the examples which are applied for concentrating the ores. Now, second step is what? Once the ore is concentrated, it has to be converted into crude metal. Okay, so second step is conversion of concentrated ore into crude metal. So, what they will do? Conversion of metal ores into oxides. Okay, so we have to convert now concentrated ore into its oxides. So, ores found in the form of sulfide and carbonates are first converted to their oxides by the process of roasting and calcination. Okay, so what are the two methods which is used for the conversion of concentrated ore into crude metal? Roasting and calcination. Okay, so when the ores are found in the form of sulfide and carbonate, they can be converted to their oxides by roasting and calcination process. Now, what is meant by roasting? Heating of sulfide ores. Okay, so if the metal available in the form of sulfide ores, we have to heat sulfide ores in the presence of excess air. Okay, we are heating the sulfide ores in the presence of excess oxygen to convert them into oxides. That process is known as roasting. Okay, so very important question. So what is meant by roasting? Heating of sulfide ores in the presence of excess air to convert them into oxides is known as roasting. Now here you can see an example for roasting process. So zinc is a metal. It is available in the form of sulfide ore. Zinc is a metal which is available in the form of zinc sulfide. When it is heated in the presence of excess air, or when it is heated in the presence of excess oxygen, it can be converted into zinc oxide, ZnO, plus sulfur dioxide. Understood, children? So what is meant by roasting? Heating of sulfide ores in the presence of excess air to convert them into oxides is known as roasting. Now, next process is calcination. So, what is meant by calcination? Heating of carbonate ore in the limited supply of air. Okay, so when it is in the form of sulfide ore, we are heating in the excess air to convert them into oxides. No, that is roasting. But calcination means heating of carbonate ore in the limited supply of air to convert them into oxides is known as calcination. Now here you can see an example for calcination process, zinc carbonate. So it is in the form of carbonate ore. Yes, zinc carbonate, when we are heating in the limited supply of air, it can be converted into zinc oxide plus carbon dioxide. Okay, so the process of converting metal to its oxide in the limited supply of air by heating carbonate ore is known as calcination. So here you can see the difference between calcination and roasting process. So calcination is done for carbonate ores. So roasting is done for sulfide ores. Then carbonate ores are heated in the limited supply of air, we have learned, in the absence of oxygen. Sulfide ores are heated in the presence of oxygen. Okay, and in the calcination process, carbon dioxide gas is released and metal oxide is obtained. Here you can see an example also. And here roasting process, sulfur dioxide gas is released and metal oxide also obtained. Okay, so these are the three difference between calcination and roasting process. So I hope that you all understand about today's topic. So continuation of extraction of metal we can see in the next part of the video. Thank you, children.